All right. So I'm Sunita Chandrasekaran from University of Delaware, and this talk is about OpenMP 4.5 validation and verification test suite. So I have a bunch of author list here. So this is one of my students, Jose Diaz. I had another student, Sergio Pino, who was working on this project until he graduated with a master's degree. And this is work in collaboration with Oak Ridge National Lab. So Oscar Hernandez, Swaroop Popel, and David Bernhold from Oak Ridge National Lab. So we started this project about 6 months ago. So I'm going to go through, what we are doing in the validation verification suite project, and who is involved, and what is the structure of the project, and how do we plan to go forward with this test suite project. So a little bit of background here. Back from University of Houston, Dr. Chapman and Matthias Muller, they have been developing the OpenMP validation suite over a period of time, and then Dr. Chapman, myself, and a few other students came up with the 3.1 OpenMP validation suite. So we have been developing these test cases over a period of time, and now it's time to validate 4.5. So the goal or the objective of this project itself is evaluating functionality of the target offload directives across compilers and architectures. And we are specifically focusing on 4.5 offloading features in OpenMP 4.5. And obviously the idea going forward is to write comprehensive test suites, so not only offloading, but we would be covering the other features. But we started off with offloading features. And this project is part of ECP Solve project, and that's why we have Oak Ridge involved, Brookhaven involved, Argonne National Lab involved. There is LLNL and LLVM, CRE and GCC. So it's a massive collaboration between national labs and compiler vendors, where we have been establishing lots of dialogue and lots of conversations with all these partners. And we are working very closely with the LLVM community currently. And we also talk to the OpenMP organization, obviously, and we would like to, step that up a bit more, involve and engage with the OpenMP standard committee more to make a, much larger impact. And we have a BitBucket where we have all the test codes and everything up there. So if you would like access to the BitBucket and the test codes, feel free to drop me an email or one of us in the contact list. So I'm trying to put the contact list in every slide so that you can reach out to us. So the idea behind this test suite itself is where we have a project workflow, where we start off with, first up looking at the specification, analyzing the 4.5 offload directive, or sometimes Oak Ridge comes up and says, hey, we have an application use case that we would like you to, validate and verify. So either that or, features in the OpenMP 4.5 specification itself. So we write a test, trying to tie it very closely to what the features definition itself is, and we discuss the validity and adherence to the specification to make sure that the test is doing what the specification is expected it to do, and we find out if the test is valid or not. So if the test is valid, we obviously test with the available implementations, and I'm going to show you in a little bit a chart with the compilers that we test this model. And if the test passes, great, we open it to the community, LLVM community to review. There is a channel where we post all these codes for the LLVM developers to make sure that this is the correct way to write the test and stuff. And if the test is accepted, fantastic, we put this into the BitBucket validation verification suite. So this is a smooth process. Now, the question is, what if the test was invalid, right? Which means, what if there was a bug? So we go back and rewrite the test case after discussions with Oak Ridge and Argonne National Lab. And then if the test was, and we go through again the discussion, validation, adherence to specification, and again we try to test it. So the question is, what if the test did not pass one of the implementation? So then the obvious things to think about there is there a problem with the test case? Is something in the specification that we are misinterpreting? Should we speak to the the compiler developers about the test case and so on? So we bring it to the OpenMP specification, OpenMP standard community, and we bring it to the LLVM community, and we talk to them and try and find out, okay, so where is the problem and why did the test fail? And then if there is a bug, we have been filing compiler bugs with the different compiler vendors. and then eventually when the bug is filed and then they report it, if it is fixed, then we retest it and we then put the final passed test case into the BitBucket. So as you see, it is an iterative process. It's not that we write a test case and we dump it in the BitBucket, right? So it's a complete cycle that goes through, right, from starting to write the test case, making sure that it is being compiled and executed by more than just one or two compilers, and making sure we let the LLVM community know that this is a test case. Are you okay with this? Is this making sense? Is this adherence to the specification, etc. And then if there is a bug, there is a whole different process we follow. So this is, like I said, the OpenMP. The current project is heavily focusing on the target offload, and that's a little, Mickey Mouse picture of, there's a host and there's a device and there's an offloading, which one of my students created, and I thought that was, quite cool. So focuses very heavily on the target offloading. So we're definitely focusing on functional and unit test cases. What we are also interested is in isolated test cases, because sometimes there are a combination of directives. And so how do you know you're testing the directive that you want to test, right? Because and sometimes the directives have to go hand in hand. You cannot separate them. So we try to create functional unit and sometimes orphan test cases. And the target platforms, I'll show you in a while the list of target platforms where the tests are currently running. And it's also a collaborative project with ECP application developers to create representative specific use cases, because sometimes the application developers have a code failing, but it's a massive piece of code. So how do you narrow down to the piece that actually caused the code to fail? So Oak Ridge comes up and says, okay, this is a particular use case which is causing this to fail. So then we trickle it down to something meaningful, which is much lesser number of code compared to the original application itself. And then we create a test case and do the entire process of the project workflow that I showed you in the last slide. So this is probably known to anybody who has an idea of what the offloading feature itself is, but to quickly give you an overview, it's a host-centric execution of code, meaning the directives provide compiler with hints to create device executable code, as well as inline all the necessary calls, code execution, data movement, with the idea being that the users add hints to their application, and that gets compiled and executed by the compiler. So there's lesser burden on the user as a programmer, right? And they're trying to do a better job with the program itself. And it frees the programmer from bookkeeping, data allocation, movement, etc. And in particular provides good control to the programmer to handle data movement between host and device, because that was the whole purpose of coming up with an offloading feature. And that's a little code snippet that shows you, device code generation, and there is a target clause, a map clause to and from and then what kind of conditional execution on the device, and the runtime decides device selection. So the current status is we have created and implemented over 20 plus validation verification test cases for structured data map directives and runtime library calls, and I will show you in a little while, how we are structuring the entire test cases. We committed patches to the LLVM compiler community and establishing collaboration with the rest of the parties that I told you. And we maintain a BitBucket, a wiki page where we have README and meeting minutes, and because there is a make file, and we have a bunch of test cases, we have a bunch of platforms, we have several compilers, so it needs to be scripted to make the whole process automated and easier. And we also have a how to use LLVM lit infrastructure, because one of the end goals is to be able to integrate these tests into the LLVM lit infrastructure. Increase a range of different compilers, so it is not just LLVM, but we also test with IBM Excel, GCC, Cray, and of course the LLVM compiler. And we have been talking to the OpenMP ARB, and OpenMP ARB has also put up a bunch of examples. So there are several codes around here and there, functional test cases, unit test cases. So what we would like to envision this is, as a community, we come together, gather codes that are already available, and find out what we have, find out what they have, and put them together and build this massive bundle of good suite. That's the overall goal. And that's just a snapshot of how we have been structuring the code itself. So if we take the target data and we have these different types of devices or different types of target platforms, we have structured each of these directive into a bunch of tests. So you would see arrays, contiguous sections, non-overlapping, allocatable, 1 level, 2 levels, simple C++ object, or multiple devices, etc. And we look at some papers that IBM had published it with IWOMP, so that gave us some more test cases to look into. And so we assign it between Oak Ridge and ourselves, and we have the test name that corroborates with whatever is in BitBucket. So as you can see, we are trying to really do a comprehensive test with each of the directives. So it is really broken down narrowly into selective test cases for each of the directive that we're dealing with. So we've done target data, target enter exit, and target enter only, target exit only. So this is the way we would isolate a particular directive and how these tests would really work. So this is one example that I thought I will let you folks know about how do we go about constructing this entire test case. So that's a code piece, and what we are really trying to do here, or what we observed, is we're trying to distribute each row of a matrix to exactly one of the available devices, so which is this one, line 3. So in line 8, initially we started to we had the Pragma OMP target map, and we did not have the from clause, but we had the device dev. So although the code ran and reported success, it happened at runtime that the entire H matrix was being copied to each one of the devices, when they were supposed to have copied like row by row, because that is the intention of the test case, to be able to offload this to multiple devices. And line 8, so that is the one, so then we plugged this H matrix array back there to implicitly suggest to the target region not larger than the original size already mapped in the outer region, which is this one. So the idea here was, without this, although it worked and reported success, at the runtime, the code was behaving as though the entire H matrix was being copied when it was supposed to only copy rows of matrices. Right, so this was the idea of this whole test case, and this test case helped us figure out that adding that kind of fixed the philosophy of the test case. This is a snapshot of the Slack channel that we use to do all the chattering about the test cases with the respective collaborators. And that's the BitBucket snapshot. And again, I put the contact IDs here. So this is a table that summarizes the list of tests, the language, and the different compilers. So here we have the Clang and Summit Dev, which is the development platform at Oak Ridge National Lab. And this is the IBM XL. And that's a Titan with K20X. Summit Dev has a Pascal 100, and this is a Cray compiler, and that's again on Summit Dev with a GCC compiler. So this is a list that shows passes and fails, and one of the ideas to be able to use, the reason to use different compilers is A, to test the validity of the implementation, and B, to find out how good our test case is, right? So it goes both ways. So instead of just compiling or executing with one compiler, we're able to find out sometimes the test is incorrect, and one of the compiler points it out. So it's an iterative process overall. So that's selective test cases that we have, showing you some cases there. And next step is we would like to extract some more test cases from application use cases to complement the ones we have. And this is work in collaboration with Oak Ridge National Lab and Brookhaven and Stony Brook here, where there are application developers writing large pieces of code, and sometimes it fails, and they need to narrow it down to a particular portion in the code, and how they do it, because it's a massive piece of code. So they have to strip it down and trickle it down to some 50 lines of code, and that way we would help them figure out where the real problem is and why the application itself failed. Exactly, so coordinating with the LLVM community, and we have been preparing for a release to the Solve project during SC. So that has been the work so far. So the goal here is to be able to work together in collaboration with the LLVM OpenMP community to bring all this together and make a big massive bundle of good test cases to validate the implementations in OpenMP compilers. Thank you.